Good afternoon or morning, depending on when you're watching this. We are taking a peek at our Quiz 1 preview for unit number 4. We're going to keep life simple. Mr. H is going to do the odds, and I'm going to leave the evens for you because you're going to have a great example to work with at that point. Let's jump in. Now, when you're doing simplifying expressions, notice the difference between these two. One's plus, one's minus. Plus is the easy one. Plus basically means nothing is changing. You're just combining like terms and you're done. The minus, though, you need to watch out and make sure whatever's after that minus in the parentheses gets the negative. The stuff before that, not so much. But everything after is going to change signs. And then it just becomes a big old game of combining like terms. So where's that biggest exponent? R to the fourth. R to the fourth. There's another one. Negative 5 plus 3 is negative 2. R to the fourth. No R to the thirds. R squared. Negative 2 minus 7 is negative 9. R squared. And R's 3R minus 3R. Well, it just canceled out. Okay. That's all I got left. So anytime you're adding or subtracting, again, see the symbol in the middle is add or subtract. If there's not a symbol in the middle, that's going to be multiply. We got to watch out for that. Because I don't want you making a big old 3x3 box for one of these, then it's wrong anyway. That's no good. So just a little bit of advice. Okay? Products. Again, we talked about this before. You can do boxes. You can do the little lines. I'll do both. Okay, that way you can kind of see which way you maybe still like better if you haven't made up your mind. A little ones on here. So one way I can do it, I can just start distributing. Again, multiply the coefficients, add the exponents when we're multiplying. So 24 n to the second. 4 times negative 3 is negative 12n, or n to the first. And then we would do the same thing with the negative 7 to each term. Negative 7 times 6 is negative 42n. Negative 7 times negative 3 is positive 21. It's just start going from biggest exponent to least, biggest degree to least. 24n squared. Combine like terms. Again, I'm not multiplying anymore. I'm not messing with the variables. Clean that up and I'm done. Bigger ones again, I can still distribute, but for fairness, okay, I want to make sure we try a little of everything here. So here, if you want it to go to the box works on any size polynomial. I still suggest putting the exponents, especially on your m's here if they don't have one, so you remember there's a 1 there. And just like before, multiply the coefficient, add the exponent. Multiply and add. Multiply. Multiply. This time all multiplying all the time. And as we've said before, the nice thing about the box is now everything's organized for us with like terms. 30m to the third minus 16m squared, because all I'm doing is adding now. 36 and 2 is 38m minus 12. And we're done. And when you get down to 7 and 8 and 9, okay, we talked a little bit about how that could be something where your middle terms cancel out. There's a plus and a minus, there's a plus and a minus. That was nice of me. But we're going to change this one. We're going to turn that into 3x plus 4 squared, so we'll get to that in a minute. Foiling works, multiplying out works, box works. Okay, the thing that I can mention on this is that we've got a difference of squares, okay? So you've got a plus and a minus with these. So what basically ends up happening, let me do a box on it so I can show you. You're like, Hardy, all talk, no math. Keep the math going. I agree with that. So if I go to the box, 25n squared minus 15n plus 15 minus 9. Check out what happens. The n's cancel. You're like, so? I mean, that's probably just going to happen now and then. No. If you get the exact same sets of parentheses, except one's plus and one's minus, okay? Those are always going to cancel out. So you can just multiply the first, multiply the second, and be done. 5 times 5, 25. 3 times 3, 9. I'm done. But only when the signs are different. Now, if the signs are the same like they are here, remember, you've got choices here. Now, if you go old school, you can still work this out. Do a box, do the distributing, it doesn't matter. I'm here on a review like this just to remind you of some of the things that sometimes we tend to forget. So I'm multiplying my coefficients. Adding those up. And I get my answer. I mean, there, easy as can be. Nothing bad, nothing terrible. We can stick with that. However, this is one of the problems we talked about with the pattern before as well. Where we said this is A and this is B. Now, if you're like, Hardy, I'm just doing this, then fast forward me through this part. Don't even listen. But if you're like, wait a minute, I remember this. Let's talk about this again. So what we're going to do is we're going to take our first term, and we're going to square it. And since there's a plus in the middle, we put plus here. 2 times the product of these two, so 3x times 4 would be 12x, plus my last term squared. So for, again, those of you at home, square the first term, 2 times the product of the two terms, square the last term. First, both, last. Okay? And then simplify it. The 3 and the x. And check us out. Same thing. Okay? Either one works. It just depends on the way that you want to do it. Now we get to the part that's the more interesting. Oh boy. So I get down to here, and we are doing function notation. So remember, there's a difference between little dot g, which is multiply, like we just got done doing, and open dot g, which is composition. So what does this mean? Remember, we always work from right to left, the opposite of what we always are thinking. So here, my first job is to plug -4 into g. Okay, so here's my g function. We always use parentheses when we plug in stuff. Okay, if you can punch that in the calculator if you want to, so that'd be 16 minus 3 is 13, but I'm not done because there's one more part now where I've got to plug the answer I just got, g of -4, into f. So f of 13. So I have to get the first part right to be able to get this right. And so now here's f, and I'm just going to plug 13 in where the n is. 52 minus 3 is 49. That's the answer. It's not two separate problems. It's one problem with two parts. But always go from right to left as you're plugging in. Okay? So flip over. Okay, what do we got? Now this time I got another one of those, except this time there's no number. So you're like, okay, what do I do now? This is telling me I'm going to take g of x. So I plug x into g. Well, I mean, that's not going to change anything. But then I'm going to plug that I'm going to plug g of x, my g function, into f, still going right to left. You're like, ew. So f is just 3 times x, 3 times what's in the parentheses, because the parentheses is always what x is anyway. Okay? So I'm literally plugging, so here we're plugging g into f. Taking this and plugging it in right there. Now we're just going to simplify. And these are a little weird because we don't get down to a single answer. We just get down to another expression, but that's okay. That's why we have more of these on here to do, so we can actually get a little more work in at this. So you're like, okay, so how's this work again? The one on the right goes into the one on the left. H into G. This in right there. So G of x cubed minus 5x is going to be, okay, here's G. I start copying. When I get to the x, you replace it with what's in the parentheses. Okay? Plug an H into G, a little distributing. And I notice no like terms. That's as far as I can go. And I'm good. Now, I'd mentioned this at the start, but now we get to see it. Open circle composition, little dot, multiplication. So we're doing f of n times g of n. And you're like, oh, so there's parentheses. So I need to do a box or FOIL or something. Right. So here, n cubed plus 3n squared n minus 3. And we're just, same thing we'd been doing on the front when we were doing the box. We're going to add exponents when we multiply. And if there are none, we're just going to multiply coefficients. Okay, let me just double check quick. I always want to make sure I'm... Okay. And then we go greatest exponent, greatest degree, plus a negative 3n cubed cancel, and I'm good to go. And so we keep going. We're like, okay, f minus g of x. So f of x minus g of x. F of x minus g of x. The only thing I'm going to have to do here, nothing here, but this negative is like a negative 1. It's going to change the signs on both of those. So this will become negative 1x to the third. This will become positive 5x. And now it's just back to a combining like terms game. $4x and 5x is 9x plus 5. And we're set there. Okay. Last one. Almost made it. And again, the quiz will not be this big. You know me better than that by now. It'll be about half this size, somewhere between like 10 and 12 questions, I would imagine. Perform the indicated operation to state any domain restrictions. Remember what that means. The denominator can't equal 0. So on 21, h over g. Okay, h x divided by g of x. Ooh, excuse me. Mercy. Now, you cannot cancel the x's. If these were, you can't, they have to be identical. That's why I put the parentheses around to remind me. The bond is strong with addition. The only way you can break an addition bond is if you have identical things in both sets of parentheses, which we don't. So this is h divided by g, but the denominator can't equal 0. So we just solve the little one-step equation. And there is my domain restriction. X can't be -3. It can be anything else, but it can't be -3. That's it for quiz 1. I think we're going to get off to a good start here, but as usual, if you got any questions, let me know, and we'll see you next time.